So Aishwarya, please read the question again.
Yes, sir. A steel magnetic structure made of a bar section 2 centimeter into 2 centimeter is shown in figure. Determine the current that the 600 turns magnetizing coil on the left limb should carry so that a flux of 3 milliweber is produced in the right limb. Take mu r is equal to 800 and neglect leakage.
Yes. So let us look at this solution. So here in the question, it is given the cross section is how much? 2 centimeter by 2 centimeter. So note the unit, it is 2 centimeter by 2 centimeter. So our area will be 4 centimeter square. You have to determine the current. Okay. And what is given in the question is the flux in the right limb. You can see this phi 2. What is given is phi 2. I have marked the flux in blue color. That is how much? 3 milliweber. And I don't know what is the flux in the middle. I call it as phi 1. And what will be the flux here, Aishwarya? That what will be the flux here, Aishwarya, in the left limb and this part?
Phi, sir.
It will be phi. And phi will be equal to phi 1 plus phi 2. So this is the only thing which you should know in this problem. So once you know the MMF, then you can find the current. We know that MMF, total MMF is equal to flux required for this yellow part plus MMF required for this yellow part plus MMF required for this blue part. So let us see the problem more formally. What is given in the question? Area of cross section is given. Please note this is a main thing in engineering. You should be very clear about units. You cannot say that I made a careless mistake. In the question, the area is given as 4 centimeter square. So that is 4 into 10 raised to minus 4 meter square. N is given 600. Phi 2 is given 3 milliweber. It is milliweber. So 3 into 10 raised to minus 3. Magnetic circuit through the middle and right limbs are parallel. Therefore, the ampere turns for these paths are equal. That is the key point here. Okay. Phi 1 S1 equal to phi 2 S2. This is one key point because we know phi 2, we don't know phi 1. So as in parallel branch in electric circuits, we know that if there are two branches in parallel in electric circuit, suppose current through this is I2 Aishwarya and resistance is R2. This current is I1 and resistance is R1. What can you tell about the equation between I1 R1 and I2 R2 Aishwarya? For parallel electric circuit?
Sir, I1 is equal to total current into R2 by
that
R1
is one
plus
formula
R2.
is there. That formula is there. Other than that, what is the relationship between I1 R1 and I2 R2? I1 R1
is equal to I2 R2.
Yes. So I1 R1 is equal to I2 R2. So in our problem, in the magnetic problem, we have this right limb and we had this middle limb. So for that, we have phi 1 S1 equal to phi 2 S2. We know phi 2, 3 milliweber. We can find out S2. We can find S1 and then we can find phi 1. That is the idea of the problem. The permeability and area of cross section are same throughout the path. So phi 1, what is S1? S1 is equal to phi 1. S1 is equal, let me write here. Let me write here or later on. Yes. So what is S1? S1 is equal to S1 is equal to L by mu 0 mu r. So here this is phi 1 and this part is S1. So what is the length of that path? Let us see here. Length of the middle path. Length of the middle path is 20 centimeter, isn't it? Length of the middle path is 20 centimeter and permeability is how much? 800. Mu 0 is same. Area of cross section is A. And what about the right path? Phi 2 is 3 milliweber. What are the length centimeter? This is 10 centimeter and this is 10 centimeter. This is 5 centimeter and this is 5 centimeter. So the total this length is 30 centimeter. So from this we'll get phi 1. From this you will get phi 1. Let me move this. Phi1 is 4.5 milliweber. So let us go forward. So total flux phi is equal to how much? Total flux phi is equal to phi1 plus phi2, which is 4.5 milliweber plus 3 milliweber. Can you see my screen?
Yes,
Aishwarya?
sir.
Yes, sir.
So total flux phi is equal to phi1 plus phi2, which is 4.5 plus 3 milliweber. And ampere turn required for the whole circuit is the sum of ampere turn required for the left limb and ampere turn for the middle or right limb. So ampere turn required for the left limb is 5 into S, which is phi is 7.5 into 10 raised to minus 3. What is S? S is, all of you know the formula for S, L by mu 0 mu r A. What is the L for the left limb? The length of the left limb is 30 centimeter, which is 0.3. 4 pi into 10 raised to minus 7 is mu 0, mu r is 800, A is this, which is 5595.3. And for the middle limb, it is phi1 S1, which we have already got. So the total ampere turn is 2 phi1 S1, 5 S plus phi1 S1. So we are done. So Ni is 7833.5. Therefore, I is equal to 7833.5 by N. N is given as 600. So we got the current is 13.06 ampere. So let me what you should understand here is that I will tell you the summary. The flux here is given as 3 milliweber, and we know that phi1 S1, this is S2, and that is equal to phi1 S1. And from this we got phi1. And once I got phi1, what is the MMF required? MMF required is the MMF for this part plus MMF required for the middle part. What is the MMF required for this part? It is part phi1. So let me ask Aishwarya to explain this problem. Aishwarya, over to you. Aishwarya.
Yes, sir.
Yes.
So given area of cross section is 4 into 10 raised to minus 4 meter square.
Yes.
Number of turns is equal to 600. Phi2 is 3 milliweber and mu r is equal to 800.
Yes. What is the question? What do you have to find out?
Sir, the current in the left limb.
Okay, current through the winding. Okay, okay. So how are you? Okay, go ahead.
Magnetic circuit through middle and right limb are parallel. Therefore, ampere turns for these paths are equal. That is, phi1 S1 is equal to phi2 S2. Permeability and area of cross section are same throughout the path. So on substitution, we get phi1 is equal to 4.5 milliweber.
Yes, what is the substitution? That is what I want to tell you. That is what I want you to tell the class. How did you get this phi1 S1? What are the values?
Phi1 is unknown. S1 is L1 by mu1 A1. L1
How
is
do you get L1?
20
How do you get
centimeter.
L1? How did you get L1?
So it is the length of the middle path, sir.
So it is given the question, isn't it? This is L1.
Yes.
Okay, L1. And then denominator?
Mu1 A1. Mu1 is mu0 mu r A.
Okay, okay. And what about this
mu
part?
r is given as 800.
Okay, okay. What about this part?
Phi2 is given as 3 into 10 raised to minus 3 Weber.
Okay,
And
that is given the
S2
question.
is L2 by mu2 A2.
Okay.
Yes, sir.
How did you get
L2 is
L2?
given in the question as 30 centimeter.
This part is the
So
L2.
it is given in the question 30
Okay,
centimeter.
okay. Now things are easy. Go ahead.
So on solving, phi1 is equal to 4.5 milliweber.
Okay.
And then total flux is equal to sum of these fluxes, phi1 plus phi2 is equal to 7.5 milliweber.
Okay.
Then ampere turns required for the whole circuit is the sum of ampere turn required for the left limb and ampere turn for middle or the right one, because they are parallel. So ampere turn required for the left limb is equal to phi s, which is given as phi is equal to 7.5 into 10 raised to minus 3, and s is equal to 0.3 by mu 0 mu r into 4 into 10 raised to minus 4. Length is given as 30 centimeter. So on solving, we get 5595.3. So ampere turn required for the middle limb is equal to phi1 s1, that is 5595.3, and total ampere turns is equal to 7833.5. So Ni is equal to 7833.5 and I is equal to 7833.5 by N, that is equal to 7833.5 by 600, gives 13.06 ampere.
Thank you very much. Thank you, everyone. Okay, bye-bye.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Sir.